Hi, this video is to talk about hypothesis test about the difference between two population means when you know the population standard deviation and you have the raw data in Excel. Okay, so this is the same problem we have been working in the previous videos. So let me show you the problem here. So we have two training centers and we want to know if they differ in their in the mean scores for students or that means in the training quality of these two centers. And then we have two samples here, one from training center A, another from training center B. We have the sample sizes, we have the mean scores, and we have the population standard deviation. And the question is, can we conclude using 0.05 alpha that no difference exists between the training quality provided at the two centers? So the first step is come up with the hypothesis. We did that in the previous video, so I'm going to skip this part. You know that this is a two-tailed test. The first, the null hypothesis that the two centers don't differ. The alternative hypothesis that they differ. Okay, so what we want to do is we want to find the z-score. We want to find the z-statistic. Remember, the one main step is use the z-statistic to see if these two sample means differ given the variability that we have in the sample. Okay, this gives us the z-score, which is the standardized score for this difference. If the standardized score for this difference is close to the zero distribution, remember the zero distribution, the standardized distribution. Let me see if I can show you here very quickly. What is it? What is my, okay, it is here. I don't want to keep talking about the same thing, but I think that's important for you to remember. So the z distribution, remember, the z distribution is the standardized distribution of deviations around the mean. So this is the mean. The mean in the z distribution is equal to 0 because nothing is deviating from the mean here. So the more you deviate from the mean, we have standardized deviations above and below the mean. Okay, so again, the first step is come up with the hypothesis, know if it's a one-tailed, two-tailed test, and then come up with the z-statistic that tells us how this difference is distributed in standardized scores from the center, which is z equal to 0. So this is equal to 1.66. We know that is 1.66 is around here. We solved this problem in the previous videos. If you want to see how to solve it by hand, watch the previous videos. This video is to show you how to solve in Excel using the raw data. So imagine that we have this problem and now you have the raw data. Let me show you the raw data. The raw data is here. So you have center A and center B, and all you want to do is test the hypothesis. So how you do that? I have some slides here to tell you how to do that. And here we have, we're going to use the data analysis tool. Remember the data analysis tool we used in I believe chapter 8 for the confidence interval. We have a test which is the z-test two sample for means. And I'm going to go over that with you now. Okay, so we have that. You must have the data analysis tool installed. We have previous videos and classes to show you how to do that. If you need, please watch the previous videos and install. So I go to the data tab and then I have the data analysis here. And then I click on the data analysis and then I have many tools, statistics tools. And then I scroll down, I have z-test to sample for means. Why is a z-test? You gotta know the differences. This is a z-test because you know the population standard deviation. We click OK, and then we have this window in which we have to input some data. The first one is, what's the variable one range? The variable one range, we always start from left to right. So this is the variable one range. Variable two range, we select this, okay? What is the hypothesized mean difference? Remember, for our class, the hypothesized mean difference, which is, let me show you. The hypothesized mean difference is always 0. I went over that with you many times. This is always 0. So if I go to Excel, this is 0, the hypothesized mean difference. What is the variance? Because it's known. I know because I am using a z-test, and the problem says that we know. So I go to the problem and I read the problem, and the problem says the standard deviation based on previous studies is 10. 10 is the standard deviation. What Excel is asking here is the variance, and I have the standard deviation. To go from the standard deviation to variance, you have to square the standard deviation. So the square standard deviation is 10 multiplied by 10, which is 100. The same thing for the second one, because it's the same standard deviation. So if I square these standard deviations, I get the variance. You have to be careful about that, okay? If it says standard deviation, you have to square this number to get the variance. Okay, so I clicked labels because I selected labels in the first row. My alpha, here I can customize what the problem is saying. My alpha is 0.05. So if I go back to Excel, that's a fine 0.05. I want the output range. I could select output range somewhere in here. I'm gonna leave new worksheet. So let's do it. Okay, simply hit OK, and then you have the results. So here are the means. If you take a look, it's the same means we have here. We have 30 and 40 observations, 30 and 40 observations, and the hypothesized mean difference is 0. The variance is 100, which is the standard deviation squared for each one. And then we have the z-score. Look at the z-score. The z-score is 1.66, the same z-score we computed by hand, which is available in our slides right here, 1.66. Okay. Then you have to know if it's a one-tail test or two-tail test. How can you know if it's one-tail or two-tail? By looking at the hypothesis. The hypothesis is that the centers differ or don't differ, okay? So it's a two-tail test. So what's the probability value for a two-tail test? 0.09. Remember, I did in the previous video and I got 0.09, the same one. If we're using the critical value approach, the z-critical would be 1.95, the same one we found in previous videos. But you don't need to do that using the Excel. This version in Excel, you can simply use the probability. So the question is the p-value smaller than the alpha level? No. It's higher. So we fail to reject the null hypothesis and have, let me put 0, and conclude that the mean scores for the two training centers are equal. Okay? Then you solve it. Very simple, very quickly. You have the answer, okay? So this is how you use Excel when you have the raw data. You must have the raw data to go over this procedure, and you're gonna have some because I want you to practice, and then you don't need to go like all the formulation that I showed you before. So 3 different ways of testing hypothesis for two population means when you know the population standard deviation. That's all.